Great, thank you very much, Paul. So good afternoon to everyone. And as Paul has rightly pointed out, I'm here today to talk about the enormous amount of educational resources that are available through the European Space Agency. And as part of a project with ESA Ireland, we've taken these resources and mapped them to the existing curricula in Leaving Cert and in Junior Certificate. So just an overview of the presentation. Just for those of you who don't know who the European Space Agency are, just to give you a brief introduction, some of their activities, who they are, where they came from. And then I'm going to just outline the partners in the project, which is ESA Ireland and ourselves, the National Centre and University of Limerick. I'm going to outline exactly where the education resources are on the European Space Agency website. But as part of the project, we've taken all of the work of sifting through all that information and trying to find out what's applicable to whatever learning outcome or learning objective you're trying to satisfy in terms of a classroom environment or lesson. And it's all been mapped to the Junior Cert and to Leaving Cert Physics, the Junior Cert Science and Leaving Cert Physics primarily. And then finally, I'm going to just briefly talk about some offline materials. There was little packs given out earlier on, I see on the DSE table. And in that bag, you should have got a book called the Liftoff Book. And in that book, there is a series of problems. And that material has also been mapped as well, so that it's applicable to the Irish system. So basically, first of all, very quickly, the European Space Agency was created in 1975, and it represents the space communities of 18 member states, including Ireland. Romania is soon to become a 19th member state. And ESA describe themselves as Europe's gateway to space. So they're about 20 years behind in terms of formation, in terms of NASA. So it was about time that they got something together, structured, put in place for the whole of Europe. So there's 2,200 people working across all the member states. And just to put it in perspective, the budget they actually have. So they've got a budget of 3.9 billion for this year. And even in the recessionary times we find ourselves in, Ireland is still capable of contributing 15.6 million, which is 0.4% of that budget, and that's just to retain its membership in the European Space Agency. Just to put that money in perspective, the Cassini probe, which is in orbit around Saturn at the moment and has been there since the late 90s, cost, not the late 90s, sorry, in the mid 2003, 2004, that cost $3 billion. So it's a big budget, but still quite small in comparison to what NASA have. In terms of the flagship projects, and this is a lot of the education resources that ESA have developed are based upon these flagship projects. The first one of these is the Ariane 5 rocket. And the Ariane 5 rocket is going to become very important over the next 5 to 10 years since the retirement of the space shuttle earlier this year. So it's ESA's most powerful rocket in terms of carrying large-scale payloads into outer space. And it's going to take over a lot of the work in terms of finishing off the International Space Station and providing further supplies and other requirements for any astronauts or other space missions. All the missions are launched from a spaceport in French Guiana. So that's the first flagship project that the European Space Agency are involved with. I mentioned the other one, and that's the International Space Station. And that is the partnership with the USA, Russia, Canada and Japan and the European Space Agency in the construction of a zero-gravity or microgravity laboratory. Ireland is not part of the International Space Station project because they aren't contributing funds towards its development. It began construction in 1998, and fingers crossed, after all the delays, it's going to be finished by mid-2012. So the idea of building this is a number of goals. You know, they're doing experiments on physics, they're doing experiments on biomedical, they're doing experiments in medicine, and a lot of the experiments that they're doing are geared towards using the International Space Station as a platform to go on and explore the moon and possibly to go on and explore Mars and get man to walk on Mars. So that's basically the International Space Station. I work for the National Centre for Excellence in Maths, Science, Teaching and Learning, a bit of a tongue twister, which I'm going to refer to as the National Centre of Excellence. Has been in existence in the University of Limerick since 2008, and it is established under the support of the Shannon Consortium, which consists of LIT, Tralee and Mary I and ourselves at the University of Limerick. And for those that here that aren't registered with the National Centre, I would encourage you, if you get a chance, to go to the website and register at the National Centre website, where you'll get announcements of CPD sessions in physics, chemistry and biology that will be held at the institutes that are members of the Shannon Consortium. The European Space Education Resource Office, which is ESRO, basically is the means that ESA use to get these education resources out there. So the idea is that kids are going to be fascinated with space. So let's exploit that. And the aim of ESRO is to basically to generate and create a repository of education resources that the teachers or the kids themselves can go to and use to add to their learning experience in whatever subject they're studying. So ESRO in Ireland is co-funded by Discover Science and Engineering and ESA. It's the 5th country in Europe with its own dedicated ESRO office. And it's quite an important addition, considering that Ireland is increasingly involved in the space industry, with up to 70 companies working in this sector in various elements of it, with regards to communications, with regards to life support systems, etc. And I would also encourage you to visit the ESRO website to register online at the website, so that you can get information, and also, what I'm about to show you in a few moments, be able to get access to the mapped education resources that we've been working on. So basically, if you go to the ESA website, you're going to see a link on the left-hand side that will bring you to the educational resources. And this is the page that you'll see on the website. Now, most of the material is contained here in what they call classical materials and online materials. Classical materials is your PDF documents, your movies, while online materials would be stuff like Flash and user interactive lectures and material. So, you know, when I was first got involved with the project, you go to the website, you go to these links. It's very, very difficult to find exactly what you're looking for. If you have a particular learning outcome, just say you're looking at measurement, and you're going to go through all these resources, which are excellent, but it can be time consuming. So as part of the mapping project, myself and colleagues at the National Centre were basically given the task of taking those materials and mapping them to, first of all, to Junior Certificate Science, and then to map them to Leaving Certificate Physics. They're also mapped to Applied Maths and to some elements of the chemistry syllabus. So, as I say, the objectives of this mapping project are to make these education resources relevant to the Irish syllabus and Irish system, to create this teacher resource which can be easily integrated into your lesson plans and to help meet your learning objectives in the classroom. And I'll show you how that's done in a moment as well. And then, once again, to exploit the kids and teenagers' interest in space. You know, for example, like I'm hearing it in the news today, of course, the NASA satellite that crash landed in the Pacific Ocean. And I'm sure that you'll go in Monday morning and you'll go into your kids, students in the classroom, and they're going to ask straight away, well, what's the story with this? Why did this happen? You know, because it's in the news, and the students are going to be fascinated about it. And this material provides an alternative way of communicating across something like, you know, when I did physics, first class in 5th year, measurement. You know, measurement, you know. I don't care about SI units, you know, nothing exciting. But some of these materials, some of the material I'm going to show you here, you can make something like measurement more exciting for the students and more engaging. So there are two types of online materials. There's a lecture type material, or a teach it resources as ESA calls it, and a second resource which is interactive, or a try it resource. So obviously the lecture resource will be something that maybe you primarily might use in a classroom environment, while an interactive or try it resource is something you may assign to students as part of their homework, or else maybe to get them to use it in a classroom in a computer laboratory. With all of these resources, it's important that before you start using them, that you make sure you've got your shockwave or your flash player up to date. So obviously they won't play. So just make sure you've got that done before you start using them. So just the procedure that was employed to do the mapping. So for the Junior Cert, we mapped them to particular topics associated with learning outcomes in physics and chemistry. So for example, the primary resources that were mapped in science came from force and energy and heat, light and sound. It comes as no surprise that when you're looking at resources coming from the International Space Station, which are going to be about the motion and living in space, that a lot of the resources that have been developed are based around physics. So about motion and about force and measurement, etc. In the Leave Insert, they were mapped directly to the content, so they represented in addition to the STS component of the syllabus. So basically, an addition to show where this particular concept or where this particular subject that we're looking at can be applied in space. And as I say, just to try and establish and strengthen clarity between physics and space, and to just give them a connection to reality, because just in Leave Insert, you know, when I see students coming into the university in Limerick, you know, they're at the stage where they're trying to see, well, why am I looking at Newton's laws of motion? Where am I ever going to use that? And why am I looking at, you know, electronic circuits? And these resources will help bridge the gap and show, well, it's important for Newton's laws of motion, because if you want to know how rockets are launched and to calculate escape velocities, that's where you need that, and similarly with everything else. So what I'm going to do is I'm just going to give you some examples of some of the mapped resources. So this here is a lecture resource on acceleration, and there are a number of little functionalities associated with it. So you've got, first of all, you've got a calculator that you can click on that will pop out to the side of the resource. You also have a little notepad. So if you were presenting this in your classroom, in a classroom environment, you could put this up and you can have these pop out either side of your actual lecture. You then have options that you can play the entire lecture in its entirety. So it'll go through each of the slides, and it starts out basically, well, what is acceleration? Introduces the idea of acceleration, or you can cycle through the tabs in the lecture at your own pace to match the material from either a textbook or another source. So just to give an example of exactly what other information is given in this particular resource. So this is an acceleration subject that we're looking at. So the topic it's mapped to is force energy measurement. And what the resource consists of basically is that it uses these things called a space truck, and it's something that you'll see a lot of in these resources, and it uses a space truck to demonstrate, well, motion in space and what happens when you apply a force to the truck, what happens when you apply a force to the truck to either accelerate it or to decelerate it. I actually found these very, very interesting, because I went on to do, this is for a junior cert, but when I went on to Leave Insert, and I did applied maths as well, one thing I found very difficult to grasp at the start was a speed time graph or velocity time graph. I couldn't see where these were coming from, and it was quite important in the kinematics section of both the physics and applied maths. Now, of course, you can use that at that level as well, but it's in this resource, it gets across the importance of what is acceleration, what happens if you move at a constant speed, what happens to your actual speed. And as you can see, the space truck will move across in fixed intervals of time and the speed won't change. But if the truck is accelerating, well, what happens to its speed at every tick of the clock? And similarly, there is a deceleration interactive slide, and also a slide which shows the truck undergoing acceleration, traveling at a constant velocity or constant speed, and then decelerating as well. So when I actually saw this, I thought this was excellent, because, as I say, it would have filled a gap for me when I was at junior cert level particularly. In terms of Leave Insert physics, I'm going to just show you an interactive one here, and this is based on the subject of electricity, and it's mapped to the electric current, and onto resistance. So what it basically is it's a little interactive kit that the students can play with, and that they can build their own circuits. So in the type of circuits they can build can include resistors, power supply, you can include a heater, a bulb, and you can include switches. It also has a set of sample circuits that are included in the kit. So for example, if you want to talk to the students about parallel resistors or resistors in series, they're included. There's also more advanced circuits there as well that talk about Kirchhoff's laws. So you can demonstrate those to maybe some of the advanced students if they want to look at those as well. Again, with this resource, there's also a calculator and a notepad attached. One important thing is that there's a tell me how, or a help tab, which is associated with a lot of these interactive try it resources. So you can just see it down the bottom there, just beside the samples, there's a help tab. So for example, student comes along to try and use it and they're not sure, well, how do I actually use it and how do I build a circuit? There's full instructions given for the students on the help tab. How do you link up the components in the circuit? How do you change the resistance value for the resistors? How do you change the power, etc.? And it's quite a great little tool to play with. For example, they could be building circuits on this and applying then circuit laws and circuit equations to test it, to see what answer they'll get from it themselves, and then of course to run the circuit and see what actually happens. So in terms of the resources, all these resources are available on the SRO website. So when you go into sro.ie, you'll see a menu on the left-hand side of the page, and on that is, there it is there, resources. You click on that. At the moment, the Junior Cert Science resources are all up there, and it is hoped that the Leaving Cert Physics, there's Leaving Cert Applied Maths for those it's applicable to as well, and there are some Leaving Cert Chemistry resources, and it's hoped to get those all up online as well for you to be at your disposal. So when you click into resources, there's a different piece of information associated with each. So you get, of course, the resource details, so the title of the resource. You get a link to the resource, which will be your flash or interactive components, which will open up separately. For the Junior Cert, the learning objective code to which the resource links to will also be given. So in this case, it's a measurement resource, OP1. And there's also then some suggestions on the resource type and how it may be used in the classroom. Maybe it's something that you might want to use as a group activity. It could be something you could use as a stimulus to engage, or something to accompany or to complement an experimental procedure that the students are doing in the classroom. So that's the online materials. So as I said at the very start, you might have got a pack there from DSC, and inside in that pack there was a number of DVDs, and there was also a book called the Liftoff Book. And this book was developed in May 2004 by the European Space Agency, cooperation between educational officers at the European Space Agency and engineers and scientists. And having mapped the material, I can tell you that the problems are considerably advanced for Junior Cert and maybe are only applicable to the Leaving Certificate syllabus. But there are problems in there that can be put into physics, chemistry, applied mathematics, and into, well, as we all know, the maths syllabus is changing, but there are principles in there that you can apply and demonstrate, for example, with regards to mathematics. Now, the thing with the book is that they have a suggested mapping in the book, in the index of exercises. So there's a suggested mapping of where the material can go. But the problem with that is that it's not specific to the Irish syllabus, and everything is mixed up. So that's, you know, it's a good recommendation. But because this book was written for Europe and all the syllabus are different, I took the book and decided to say, well, I'm going to try and map as many or of all the exercises to the Irish syllabus. There are actually a couple of exercises there that are very, very advanced, and they would be for the most advanced students, I would say. And there actually is one or two that are even undergraduate level physics, first year level physics. So just to give you an example of some of the mapping that comes out of the book. So for example, problem 2 is on the Ariane 5. So a lot of the problems, as I've shown, as I was saying at the start, are related to either the Ariane 5 or the International Space Station, or activities based around the two of those. So you'll find that with the online flash material, and you'll also find that with the Liftoff book as well. So in this, in the mapping of this, well, it's primarily mapped, of course, to the physics syllabus. So you're looking at Newton's laws of motion, you're looking at force and gravity, and of course it would be applicable to applied maths as well. And then there's a secondary mapping associated with it, so you're looking at converting of mass to tons, you're looking at scientific notation, there's vectors, and there's algebra and equation manipulation. Every problem, there's a solution provided. And of course the solution will vary in detail. So in terms of my analysis of this solution, it includes the primary equations without specifying the principles. Of course, this is a suggested teacher solution, so it's, of course, you can add more into it as you see fit. One thing I would say is that there's no diagram showing the individual forces acting on the rocket, which would be, I think, is an important message to get across to the students about what direction the forces are acting on this particular rocket. You know, just looking at the equations again myself, I'd say, look, well, you know, could have included an extra term there to explain where everything is going. As I say, this should only be used as a guide because, of course, there could be information missing from it. There is a couple of errors in a couple of the solutions, in a couple of the problems in the back of it as well. But one great thing about a lot of the problems is that it gives you the question, gives you the solution, and at the bottom of everything then there's always a little quirky fact or something related to space. So in this one here, they tell us that the boosters will work for only 130 seconds, and that's enough to get it to a height of 60k, and then they're jettisoned, and then it goes on the primary booster. So with every problem that the students would be working on, there'll be a little piece of information or extra supplementary information based upon space and space-related activities. So just to give you a summary of the presentation, so I've shown you some details of the online and offline education resources from the European Space Agency and the ESRO website. I've shown you just some sample mapping of the materials to Junior Cert Science and to Leaving Cert Physics. Currently the Leaving Cert Physics mappings for the online materials hasn't been set up on the website, but that will be done very soon. And I've shown you some mappings to the offline materials for Leaving Cert Physics, and I'm sure if you've all got the pack, you will all have the Liftoff book. And that's it, so thank you very much.